Okay, so today we're back to solving systems of linear equations. So we're done with the inequalities for now. We're back to solving systems of equations. And you remember the way we solved them before was by graphing. We would look for the place where the two lines intersected. The point of intersection is the point that satisfies both equations. You might have thought, well, this has a weakness, right? It's all depends on the accuracy of your graphing, and so we'd rather, have a method that does not just depend on being able to graph extremely accurately, and so this method is such a method. Um, it's solving systems of linear equations by substitution. Okay, so the idea is to substitute in order to get an equation with only one variable, which we can solve. And then we plug that value that we get in for that variable, and then we'll have an equation that only has the other variable, and we will solve that. So this will make more sense when we look at some examples. So here's example 1. And we have these two equations right here. We want the value of x and y, that is, we want the ordered pair that makes both of these true. So these are two equations, and they're in slope-intercept form, so they both have y on the left side of the equation. So we can actually set those two expressions for y equal to each other. If y equals this and y also equals this, then those two things themselves must be equal to each other. So we just set that equation. Okay, and now we can solve this for x, because this now is an equation with only one variable. So we'll get our x's to one side. Let's add 6x to both sides. Okay, so on the left, we add 6x. It will cancel with the negative 6x, right? And we'll just have the 22. And on the right, 6x plus 2x is 8x. Okay, and we have the negative 18. Okay, so we want to get x by itself, so we're going to add 18 to both sides now. So on the right-hand side, when we add 18 to that side, that will just leave the 8x. Okay, it'll cancel with the negative 18. But when we add 18 to the left, we will get 40. So we're almost there, and now, of course, we will divide both sides by 8. On the right, we divide that by 8. It just leaves x. On the left, when we divide that by 8, we get 5. And we've got 5 equals x. Okay. So we know that's the value for x that will make both of these. That's the x-coordinate, I should say. That's the x-coordinate of the ordered pair that will work for both of these equations. But we need the y-coordinate, and that's easy to get now that we know the x-coordinate. We just take that 5 and plug it in for x in either equation. Okay, so we'll take the first one, y, which is y equals 2x minus 18. We plug in the 5 for the x. What do we get? Y equals 10 minus 18, and so y equals negative 8. So we now have an ordered pair. X is 5, y is negative 8. Okay, so that's the method of substitution. And it's pretty easy to get started when you have both of your equations with y on the left. You just set those equal to each other. Okay? Okay, so let's look at example 2. Now here, we don't have quite the same thing. It's not quite as easy, perhaps. We have y equals negative 3x plus 5, and then the other one doesn't say y equals. It's got 5x plus 5y equals 15. So this is still pretty convenient, though, because we have y here in terms of x. Our first equation has that. So we can take that expression for y and we can plug it into the other equation. So our second equation now looks like this. 5x plus 5 times y. Well, what's y? Y is this. Okay? In terms of x, that's what y is. So we just take that, negative 3x plus 5, plug that in for y. You see, that's where we are right now. We're right here, and for that y, we plugged in all of that. Okay? And we did that because our first equation said y equals that. So, and then that's, let's see. No, that's it. Okay, so, 15. So we have essentially 5x plus 5y equals 15. We've rewritten it 5x plus 5y equals 15, except in place of the y, we put this expression for y that came from the other equation. So let's solve this for x. This is a big equation that has only x's in it. So that's not too bad. We distribute here. 5 times negative 3x is negative 15x. 5 times 5 is 25. And on the right it's 15. Now we take the 5x plus the negative 15x, combine that to negative 10x. At the same time, we could subtract 25 from both sides. Okay? Well, let's do that in a separate step. We'll just rewrite this. Now we'll subtract 25 from both sides in order to get the x by itself. So you have 10x over here. Subtract 25 from that side. And it's gone from the left. And on the right, when you subtract 25 from that side, you have negative 10. So we're almost there. We just divide both sides by negative 10 now. And on the left, that leaves just x. And on the right, negative 10 divided by negative 10, that's 1. Okay, so x is 1. Well, that tells us the x value of the ordered pair. We need to know what y is, though. Wait, what is y when x is 1? What's the y value? So we plug that 1 in for x in either of the equations. It's more convenient to use this one. Y equals negative 3x plus 5. Okay? And when we plug in for x, we will find out what y is. When x is that value, which is 1, I'm just plugging in the 1 for x. So y equals 2. Okay, so that is our y value, and our ordered pair, then the solution is 1, 2. Okay, let's look at the next one. Now this is a little bit different. Neither of these gives us y in terms of x in this next one. Okay? So we're going to have to do a little bit more work because what we did in example 2 was we took this value of y in terms of x. That's what we plugged in to for y in the other equation. So we need y in terms of x. We just picked the easier one to do. Okay, so which of these is easier to solve for y? And I would say it is the second one, right? Because it already has y by itself. That is I'm sorry, it has 1 as a coefficient of y, and so that will it's more convenient to solve it. So let's rewrite it over here. Solve it for y just means all we have to do is subtract the 2x from both sides. And on the left it leaves just the y. On the right, negative 2x plus 9. So now we can take that. We can plug that in for x in the other equation. I'm sorry, for y in the other equation. The other equation is 5x. And I'll rewrite it again. No, I don't think I need to. We'll just we'll plug in 5x plus, and we're looking at this equation here. Okay, plus 4y, but instead of y we say 4 times this, right? Negative 2x plus 9. We can substitute that in for the y. Okay, because it equals y. And so, finish that out, equals 24. So again, we plugged into this one, plugged in to that one using this for y. Okay, so we solve this for x. 5x plus negative 8x and then plus 36 equals 24. We'll combine those x terms. It's negative 3x. And while we're at it, we'll take this 36. We'll subtract it from both sides. Okay, so on the left, it's not there anymore. And on the right, we have 24 minus 36, which is negative 12. Okay, and if you don't follow all those steps, they're just the normal algebra steps. And when you do these problems yourself, you can just write down a little bit more. But this is just algebra. So, we're solving an equation for one variable. So now we divide both sides by negative 3. On the left, it's just x, and on the right, negative 12 divided by negative 3 is 4. So that gives us x. Now, we need to find out what y is, though. And we could do it two ways. We could go back to one of these equations and plug in for x, or we could use this. We solved for y in terms of x right there, right? So we can plug in x, we can plug in 4 for this x here, okay? And that will give it to us. So that will give us y. Y equals negative 2. We're going to plug in the 4 for the x, plus 9. Y equals negative 8 plus 9. So y equals 1. Okay, so our ordered pair, the x is 4 and y is 1. Okay, we have one more, just a little bit harder. So this one is similar. It just doesn't have that nice convenient um, y in it with a coefficient of 1. None of these has that. Okay, so we have to decide which of these do we want to solve for y, because we do have to solve something for y in order to be able to substitute. So, well, let's, this one is easier. The second one's easier because it has this -3 and also 3, and when we divide, we won't have fractions, okay? So we'll use that one. So we'll write it over here, and we'll solve it for y. So we add 3x to both sides. On the left we get 3y. On the right we get 3x plus 12. And then, oh, sorry, 3x minus 12. Okay, so now we divide both sides by 3. Go ahead and write that one down. That means dividing each term by 3. Okay, so y equals x minus 4. And so now we have y in terms of x. And so that expression, x minus 4, can be plugged in for y in the other equation. That is the first equation. It has to be the other one. We can't just plug it back into the same one we solved for. That will just be going in circles. So we take negative 2x plus 5 times y, and for y we use x minus 4, equals negative 20. And so we take negative 2x plus 5x. 5 times negative 4 is negative 20. Just distributed. Now the 2x and, no, sorry, negative 2x plus 5x, we combine to 3x. While we're at it, let's add 20 to both sides to get rid of this negative 20. So on the left, we just have the 3x, and on the right we add 20 to that side as well. Well, that also is negative 20 plus 20, so that's 0. Divide both sides by 3, you get x equals 0. So we have x. And we just plug that in for x in one of the equations. We will take this shortcut. We'll use this one here. We can plug in and find out what y is, right? So y equals x minus 4. Well, x we just said is 0. So put in a 0 for x. And y is negative 4. And now we have our ordered pair. X 0, y negative 4. And that's it. So again, the general rule is you have to have y as y expressed in terms of x, and then take that expression for y and plug it into the other equation for y. Then solve for x, and once you have x, you can plug that value in for x in either of the equations, whichever one works out the easiest, and then solve for y when x is that value, and then you have both points. So, or both coordinates, I mean, of the point. So that's it. That's some examples. That is solving by substitution.